I'm here in Nome, Alaska, where Xtreme Habitats and XHab are working on printing this home. We're going to watch some more of these walls go up and see how the unique XHab printer handles these challenging conditions.
Getting all of the equipment from the lower 48 to Alaska was a challenge in and of itself. They used this C-130 plane and hitched a ride with the US military. Resourcefulness will be a common theme throughout this video. People in Alaska are incredibly tough and capable. There's no next day delivery from Amazon. Here's the empty job site before work was started. It's located right next to a local club called the Arctic Native Brotherhood, which I joined while I was in town. Due to the extreme weather conditions and freezing in Alaska, they have an insulated slab. They've also installed radiant heated floors, which is relatively uncommon in this region. Here's some musk oxen I was able to see less than 300 feet from the job site. The objective of this project is that Xtreme Habitats and XHab 3D can work together to prove that 3D printed construction can be a superior solution to alternative methods in the extreme conditions of Nome, Alaska, by building something that will withstand the elements and last longer than other solutions people are currently using. In addition to extreme temperature fluctuations, Nome is also located right next to the ocean, which only amplifies their extreme conditions of weather. An abundance of sand nearby and high winds combine to essentially sandblast the exterior of local buildings, rapidly accelerating the wear and tear. That doesn't mean it'll be easy, but XHab 3D specifically designed their printer for situations like this. Let's check out their incredibly unique printer. They've got a robotic arm mounted to this lift system on treads that's mobile. In the middle of the screen at the very back, you can see a yellow tripod, which is being used to help the printer have self-awareness of its location on the job site. That way, when you place it in a new position for the next wall, it understands that it's not blocking anything, and it'll be able to reach all of the important equipment to operate the printer, like the mixer pump system you can see on the right. They're loading material through the top of the system, and it then gets mixed, pushed through the hose, and extruded out the printer. Their team worked long hours in the rain without any complaints and a positive attitude the whole time in the pursuit of revolutionizing the housing industry. This team is amazing, not only because they were able to design their own material, their own printer, and complete this project up in Alaska, but also because of how open and transparent they are. They truly want to advance the industry, and they weren't afraid to share challenges and struggles they were facing along the way. One challenge they had was their dry mix. It had rocks too large that would get clogged in the hose, so they needed to sift through the material before loading it into the printer. Jeff came up with this screening solution. By placing the screen above the mixer pump system and sorting all of the material through the screen before it gets mixed, they're able to remove all of these larger rocks and clumps of fiber that were in the dry mix before it goes through the printer. From this angle, you can see inside the wall, where they have horizontal reinforcements and also a giant space for insulation on the left side, which will be a spray foam insulation that I'll show you at the end of the video. Take a look at the little fluff ball falling behind the mixer pump operator. That's polypropylene fibers included in the mix to increase tensile strength. Unfortunately, probably during transport, they clumped together. A mix that didn't have these challenges would be much easier to print, but it's Alaska, so they made do with what they have, and I'm sure they'll apply what they learned to future prints and decrease the amount of labor relative to this job.
Hello, my name is Cliff McHenry. I'm the City of Nome Building Inspector, and I'm excited to see the project up here. We have some very challenging conditions for getting construction done up here. Some very challenging soil conditions, and I'm anxious to see something like this maybe on a more conventional foundation, because the slab's very expensive, and a lot of the outlying areas they don't have the concrete batch plant. And the city's going to be owning this building when it's completed, so I'm happy to be involved in witnessing the construction. It's all new for me. I've never been involved with this.
Are there any inspections unique to a 3D printed building that wouldn't be involved in a regular building?
Well, during the concrete, I did inspections, pretty standard rebar, footings, etc. And actually, for me, I just observe it because we don't really have a punch list per se for the building itself. But once it's completed, the electrical, the room sizes, egress issues will all be addressed.
Very exciting to see cutting edge technology here in Nome, Alaska.
Yes, and for the outlying areas where they don't have such challenging soil conditions. Yeah.
Thank you, Cliff.
Thank you.
With the first wall complete, it was now time to clean up and move everything to the second print location. This is particularly easy for these guys because their generator is on the printer itself, so it's one less piece they need to fit in the logistics puzzle. To move the printer, they control it from a laptop, in this case sitting inside of the printer itself. You can see the program shows the printer where the slab is, what parts of the wall it needs to reach for the print, and where the printer is relative to those sections.
The actual location is blacked off the location of the right reflector. So we need to fit it inside that area. So we might just go back just slightly. Okay. So it fits
After they have the printer in location, they lower these control arms that help stabilize it during the print. Notice the rebar sticking up from the corner of the slab. This will align with the interior wall that will receive a backfill and additional vertical rebar so that you have columns poured in concrete throughout the building. Next, they lower the feet in the back of the printer, and once the treads are lifted off the ground, they're ready to get the mixer system going and start printing. I was impressed by the ruggedness of their system, able to operate under these rainy conditions. They would tarp up the printer overnight, but during the day, it was getting rained on constantly, and only really had one challenge. It was towards the end of this print day that they noticed an error in one of the sensors of a joint on the printer. Upon further inspection, they noticed a crack on the sensor's cover that was letting water in. So they dried it out and were amazingly able to get it printing again. I think it's so important companies like this test their own equipment in extreme circumstances, even to the point of failure. They will be increasing the weatherproofing around these sensors in the future so that they won't have to deal with this problem again. I love witnessing the cutting edge of construction because you get to see improvements like this in real time. Witnessing struggles really gives you an appreciation of technologies that people will probably just take for granted in the future.
Hi, I'm Keith Comstock. I'm the Executive Director of Xtreme Habitats Institute, based in Juneau, Alaska. We're here in the city of Nome, working on a 3D printed house for a HUD grant. Well, we're kind of a twofold mission statement. We're basically looking at how automated construction and how to apply automated construction to reduce the cost of housing, especially in rural Alaska, where we have some of the highest costs in the world. But we're also looking at how automated construction might actually allow us someday to do this off the planet as well. But for now, we're focusing in on doing it in really difficult places in the world, like here in Nome. And we figure if you can't do it in a community like Nome, Alaska, you're never going to do it anywhere more difficult than this. Certainly not on another planet.
What are some of the challenges of building here in Nome, Alaska?
The challenges of Nome are multifaceted. This is about the limit of things that can be supported. We at least have air traffic, air cargo coming in and out of here with Alaska Airlines, so we can get a large plane in here. In the summertime, we can bring in barges with equipment. Of course, for about half the year, the sea ice here is frozen, so things can't go in and out. So basically, if you don't bring it in between late May and September, you're stuck until another year. So there's not a Home Depot here. There's not a lot of the kind of things that you might come to expect in a normal thing. You can't drive to another town. We're about 500 miles from air. at a minimum to the next town of any size. Which basically the closest thing from here is back to Anchorage, which is about an hour and a half flight on a large 737.
What makes your printer uniquely capable of these challenging environments?
Well, we worked to develop this printer with folks at XHab to basically meet the needs of rural Alaska. And so the idea is that we wanted a printer that was small enough to fit in a 20-foot Connex container. Not only the printer, but the mixer and the hopper and everything else that would go with it would fit into a 20-foot Connex. That's a really important size, because as you get to smaller communities than Nome, usually they can't take a container larger than 20 feet, whether you're hauling it over the ice during the winter with an ice truck, or you're doing whatever you're doing. 20 foot's kind of your max, and so that was important that everything fit into a nice neat container, roll out on its own power, that it have its own power. This has basically a diesel generator set that will power not only everything that we need for this, but other things as well. It has an air compressor. It has all kinds of cool things along with it. So we basically bring our own our own power plant to the job.
I've got a million more questions about how you started it, what your future goals are, but let's save that for the more lengthy podcast discussion. People can check that out at the link in the description.
That sounds fantastic.
Hi, I'm Bruce Kraselsky. I'm the CEO of XHab 3D, and we're based in State College, Pennsylvania. And our business model is to design, engineer, and build 3D concrete printing systems as a first product towards ultimately a whole range of products that automate the construction site. So our strategy from the very beginning was to focus on designing a 3D concrete printing system that would meet the most challenging performance and durability requirements, not just of working in places like Alaska, but also the U.S. military in expeditionary or contested environments. The thinking there is that if we can design a printing system that will work in those places, that we'll have a better system, and its suitability for the more benign commercial environment in the lower 48 should give us a competitive edge.
Will you be selling these printers?
Yeah, we'll be selling them, and we also have a rental model that'll be coming down the road, so that we can penetrate deeper into the market, and people will be able, with the appropriate training, to rent the machines for shorter durations and maybe even rent to buy. We're looking really at 3 different market segments for our printer, at least to begin with. Clearly the government is one, and I've described why, because of their extreme requirements. The other is the university academics sector, and there are a whole range of uses for this printer in that setting. And then the biggest market, though, is, in our view, the construction sector, and that really breaks down to residential, commercial, and infrastructure. And the ideal customer in that regard is one that has deep experience in a particular trade. For example, a contractor that already has something to do with buildings or residential housing, and is interested in automating what they do and maybe expanding into ancillary areas with this robot printer, which we see as a productivity tool. And our objective is to embrace folks like that and work with them through training and hands-on support and service to make sure they're successful. And what we want to do is ultimately build an ecosystem so that as they expand, we bring opportunities to them. We tie them in with folks that can help them out, say on the materials or architecture or other areas that would make their business easier, so that everybody wins.
Horizontal reinforcements are placed every 12 inches or so. The printer has no problem gliding right over these reinforcements. Unfortunately, this is about when the weather started to turn. A little bit of rain might even be good for the print because it extends the curing period and keeps everything humid. Too much rain will ruin the process, so they did need to stop and clean up. The cleanup process for the printer is fairly easy. You run an orange sponge ball through the hose with high pressure water behind it, and when it spits out, the hose should be cleared from all the sediment. They do a quick waterproofing of the printer, specifically the robotic arm, with a tarp, and they lower the tent above the mixing system and the dry material. It's a good thing they packed up because the weather really took a turn for the worse with high winds.
Jared, one of the more obscure areas of scientific research at the moment is an area called Archology, and that's a mixture of architecture and ecology, and it's basically creating a self-sustaining environment, for folks to live and survive. And it includes every aspect of life, from buildings to food production to just everything that you would need. And so certainly folks who are looking at a moon colony or a Mars colony, right now that can only happen with massive support with spaceships. Like even the space station, if folks don't come every so often with resupplies with things like oxygen and food and everything else, everybody up there is going to die. And so here in remote Alaska, we face some of those same issues that that unless you want to live just a bare subsistence lifestyle, we're totally tied to the world's supply system of aircraft and ships, and bringing basically food and supplies. And so Alaska has the challenge that if we didn't have, if there was interruption like it happened temporarily during 9/11, or if there's a war or some sort of major calamity, whether it's an earthquake or a tidal wave or a pandemic, that basically we'd be cut off here, and within a matter of literally weeks you could face starvation. And so one of the things that Xtreme Habitats is looking at is, we're focusing right now on how you might build an archology, how you might build a building. Other folks, like the folks at University of Arizona with their famous biosphere project, we're looking at how do you get an atmosphere, how do you get air to breathe. But for us, it's very important that that we learn how to build things, but then also how to then self-sustain ourselves, whether it's using things like 3D printing, not just to print the house, but other kinds of 3D additive manufacturing to make objects or make things that we might need in order to live or survive.
Back at the print, the old layers have become quite solid. In order to ensure there's a good bond between the old layers and the new layers about to be printed, they dust off the top layer with an air compressor touch printer and mix this slurry that will be applied to the top of the old layers. That way it bonds well with the new layers and you get a nice monolithic structure.
I'm Daniel Gilpin. I live in Nome, Alaska. Jeff hired me to be a laborer on the job here. Me and Dylan are filming the pump over here. We're filling the concrete, pushing the concrete through the pump.
How long have you lived in Nome?
30 years, I guess.
Have you ever seen anything like this here before?
I've never even heard of it till I seen it. These guys come up with it. But I've been here a long time, so I'm not in the real world.
And how do you feel about the, you seem pretty good at operating the mixer at this point. It's been a few days. You caught on?
It's nothing. I've operated lots of machines through my life.
Very similar?
No, just heavy equipment, all kinds of different stuff.
Sweet. Thank you.
Hey, I'm Jeff Berlin, the VP of Construction of XHI, here and working in collaboration with XHab to be able to do this 3D print here in Nome, Alaska.
How long have you been doing contracting?
God, I'm second generation. I took over a trucking company from my father back in the 90s, and a successful builder doing residential custom homes, got into commercial, and known Keith for a while, and so here I am with XHI in this project.
You've done a few nice MacGyver tricks on the job site to make the project possible.
Yeah.
One was the screen you developed. Can you talk about that?
The screen.
The screen to sort the material.
Oh, so we ended up having material that had an inconsistency in batching. It had some strata. It was different things that were different layers of the material that were laying up in the bag and weren't mixed correctly. We also had an abundance of fiber into the mix, and those things were causing inconsistent prints and jams in the printing. So we just, MacGyvered a field screen to be able to handle that, and if you ever get a shot of that when he's doing it, you'll see the kittens that we're pulling off with extra fiber that are unnecessary, that were given its fits in the beginning, but we had to overcome that situation. And then of course, we have kind of a constructed lean-to here because we're in Nome. Weather's a real factor. In this time of year, it's constantly drizzling. Usually the wind's blowing harder. Sometimes the rain's really going. But we had to build that to be able to overcome the elements. We had a much lighter tent, but that didn't last long.
Xtreme Habitats Institute is a 501c3 research institute recognized by the IRS. We're trying to bend cost curves in rural Alaska. It's very difficult here, and we do accept donations. We have a real need for high-quality used vehicles that could be brought to some of the villages and left because it's so expensive to transport them back and forth. We also, can use just basic tools. I know that folks will standardize on the red tools or the yellow tools or maybe the green tools. And so if you're that person and you have an extra red tool or an extra yellow tool, we don't care. We'll take anything. We really appreciate your support from your listener community.
My name is Sven Guilin, and I'm the lead for systems engineering at XHab 3D.
What were some of the design considerations you made when making this printer?
Well, we took a systems approach when we began, and we looked at what the end user is going to need. They want essentially mobility, autonomy, being able to work off the grid. So that meant being able to provide all of the necessary components, on one platform. So they also, that meant that we had to be able to fit it within a certain volume. So those high-boy connexes over there, it needs to be able to fit into that, roll right out of that, roll onto the site very quickly, and be set up and be working ideally within, an hour or so when everything goes well. The generator was sized to be able to provide all of the power to run the hydraulics, all of the power to run the mixer and pump. We also have auxiliary plug panels on the side to run power tools, those kinds of things. So any of the kind of things you would need on site, you don't have to bring your own generator on the site. It does have a ship to shore or ability to run off of external power. That's what we provide here. So if it's in an indoor facility or you're on a job site where you can provide 480, then essentially everything can be run off of the external power. You'll see on the back there that the plugs that essentially go to the external pieces, as well as the plug that allows it to go internal. The power plant was sized to be able to run a hydraulic pressure power unit, essentially. So we run an electric motor to pressurize the hydraulics in the system. That's to be able to run the tracks as well as the lifting mast, and to be able to deploy the outriggers on the machine. Another important feature was to be able to carry the robot controller and to keep that in a vibration-free environment. So we have some vibration stabilizers, leveraging some of my experience for how things are done on Navy ships, military transports, etc. And then, of course, we wanted the electronics and housing and the user interface to be all in one location, essentially from a safety consideration on all three sides, as well as on our tablet. Essentially, we have switches. Essentially, we slap them, everything stops. That also drove another design decision that we had, was that while this thing is at a fully extended and moving at maximum velocity, if somebody hits stop, this thing can't get all torqued out. One of the other design decisions that we made was essentially that we want real stability in the system so that we get very, very good print quality. And so you'll notice that this is probably one of the most stable platforms out there for print quality. And that's done by essentially having that lifting mast, and that was designed with that in mind, that essentially this will be extremely stable at even the highest extents in the furthest reaches.
Someone mentioned it's a 12,000-pound machine, right, but the robotic arm is lighter than a lot of the other robotic arms.
Right. And so we go with the Scala robot arm, which is maybe about half the weight of some of the other robot arms on the market. We did a cost-benefit analysis essentially for lightening that versus what we actually need to have at the robot, at the actual extender tip of the robot. and determined that that carrying capacity was enough for us to be able to do all of the work that we need to do with our robot system.
And the lightness probably reduces vibrations too, right?
The lightness of the robot, right, essentially, so there's less inertial mass to have to stop and all those kinds of things like that. So that was a very important design decision that we made. We also made it so that, yes, as you're seeing here out in the field, we're having to innovate in real time, essentially, to be able to do things, and so the ability to kind of, get into the system and be able to make the changes is also viewed as very important. And that was driven by sort of our military customers, because they're very, they're going to be out in these kinds of environments where they're going to have to innovate in real time to be able to do what they need to do. So, that's very important.
Are there any upgrades coming soon to look forward to?
Well, we're always looking at upgrades. So this is our second beta prototype named Betsy, and we've been taking the customer feedback, integrated those into the new, essentially our products that are out there. But we continue to innovate, and our customers receive, for the first bit, they receive those innovations as we implement them. So,
nice.
So things that we've implemented, like for instance, things that we've implemented since this release is automatic leveling. So we had everything in place to be able to do that. Now we actually have sort of the code to be able to do automatic leveling on site.
You were monitoring something over there. What's that?
That's the pressure. It's 2021, which is good. It's good. 2021. So that's the pressure in the pipe. I mean, people that are familiar with the MTEC system will know sort of what the pressure needs to be. That's for this mix here on site, here in Alaska, that's kind of the sweet spot that we're trying to target right now while we're working.
Well, the print's going pretty good. Thanks for taking the time during the print to explain all that to me. I appreciate it.
You're welcome. Thanks for coming out.
If you made it this far in the video, you're in for a treat. After the print was complete, I did an interview with Keith, and he shared a ton of the struggles they faced, which many other 3D printed construction companies also deal with too. But it's rare to hear somebody speaking so candidly about the realities of printing on site. Huge shout out to the transparency demonstrated by the Xtreme Habitats and XHab teams.
Wall section number 5 nearly broke us. As you were there, you saw the material problems we were having with the contamination, aggregate of the wrong size, and moisture that was making some of the material unusable. And we got into several bags that were not thoroughly mixed, and so we were having wide fluctuations in either the amount of silica fume or limestone fines or whatever. And it was causing the water mix ratio to swing wildly. It became obvious to us that we were not going to have enough good material left. We fought through that wall, and then the weather took a bad turn on us as we were starting wall section number 6. And so when the viewers are looking at the video, they'll see where our print goes from a nice charcoal gray everywhere to all of a sudden we have white cement. This is Sunday, October 5th, and it's about 3:30 in the afternoon, and we are printing again. We've received the new material, and right now we're no longer printing under a bubble. It's warmed up just a little bit, and we're getting ready to tent up again. You'll see the scaffolding, and you see those big pieces of ballast. That is us reusing the materials that we couldn't use for printing, so we're using them currently for ballast, and then we will reuse that material up to do the concrete pours in the columns. Our good friends and partners at Sika helped us get that material. We were able to buy that material from Sika and then get it transported to Alaska. We made the decision, because we were running out of weather and time window, to try to expedite it as quickly as possible. And we were going to have to bring more raw materials to Alaska to then mix it ourselves, or we could just get it pre-mixed from Sika and bring that to Alaska. And so that was the decision we made.
Sika has been a big player in the 3D printed construction space for years. I believe they produce more 3D printed concrete than any other company in the world. Noah Callentine is one of the foremost leading experts on printing concrete, and when he shows up with his Sika material, that's not where his expertise ends. I've seen him helping with all kinds of challenges on printers, many of which have nothing to do with the material at all. One crazy example is when a printer was struck by lightning, and he jumped to the rescue. That's why I picked Noah to present the latest section of my course, which describes how to print with Sika materials. You can check this course out for yourself at the link in the description below. Make sure to get in soon before Black Friday pricing expires.
We have these heaters here, heaters that are blowing up this green bubble. We're in the middle of a storm here in Nome that's only going to get worse as the evening continues. We're expecting gale force winds up to hurricane force winds. At some point, this green bubble will be torn to shreds. We'll see whether or not we can get this last wall segment printed before this October storm puts an end to our efforts. It was so windy that it was starting to actually get you separations on the veneer layers and making the that concrete wall look like a Venetian blind. It was a little windy, and we're getting snow. We basically tented the remaining area and had a pretty good success with it. But then we were getting severe storms. We basically went through, Jeff and I and others went through with X-Acto knives and basically cut it down. We were waiting for that storm to blow through, and we had a really short window. And we had a couple of days of like blue sky weather. We used that to the best of our ability. We tented up. We basically finished 7 of the 8 walls. We moved the printer outside and repositioned, secured the whole site for the last 20-foot segment. The walls are vibrating and shaking because it's ripping and roaring. We did get it finished. We did. We were able to. We had enough time to properly unroll it. We didn't have to cut it down.
About halfway through the pour, we're pouring hydrophobic foam into the voids of the outer cells of the wall structure. It's working beautifully. We came around to the side where we had experienced a lot of stratification in the mix that we were using. We're actually inside the building pouring the foam, and I was working on installing some other window frames. And we hear this, what I can only describe as if the ship were like creaking and moaning in bad weather. And when we located what was going on, we just sat there in disbelief as we watched that foam push out that segment that didn't adhere. The beads didn't adhere well to themselves due to the stratification and too much sand.
It's worth noting this exterior portion containing the foam is non-structural.
So when we poured that foam, it actually busted out a section of the exterior cement. Ended up fixing that by using Sika's bonding material, which is incredible stuff, I have to tell you. When I did the repair, it was 26 degrees. We had to use the heater to heat the material and to heat the Sika material to join the pieces back together. Put it back together with by custom cutting each of those pieces and refitting them back in and filling the voids with Sika. In other words, kind of, setting mortar and brick, if you will. Only with this, it's the cement wall and using the Sika material as the mortar. After the foam, then we poured all the columns and installed the rebar into the walls. I did not get to do the bond beam because temperatures were 26 and not getting any higher, and they don't have antifreeze additives in Nome, so I had to leave that out. So I protected that area, covered it up, and left it.
It's kind of fascinating that you had a crack in the foam from the foam, but not from the poured concrete, which is so much heavier, I would think.
Well, it just goes to show you that it wasn't a function of the normal concrete issue. The function is that in that particular area, and Keith remembers it well too, as did the XHab team when I talked to them about it, that was the area where we had a lot of stratification, where we had a lot of start and stops because it was spitting out really dry material.
How cool are these guys? It's rare startups will talk so openly about challenges they might face on the job site, but this is a prime example. I had a ton of fun making this video, visiting Alaska, Learning about XHab, I can't wait to see what's in store for them next. I'm sure they're going to continue to build incredible things. As of now, there's only one state I haven't visited, Hawaii. I think it's only a matter of time before my journey to document the evolution of construction takes me to 50 out of 50 states. Someday, people might forget what construction used to look like. The goal of this channel is to have a historical reference for people to see how construction evolved from manual labor to a robotic construction site. Xtreme Habitats has cemented themselves in history as a contributor to the evolution of construction, and I'm sure their story doesn't end here. Make sure to follow along on their social media as they post more regular updates than I'll be able to. I look forward to the next time I get to film with them in the future. This is just the beginning. Next time we visit this group, I'm sure they'll have a ton of advancements, some of which were discussed in this video, some we never could have seen coming. When it comes to construction in Nome, Alaska, it truly takes a village. Xtreme Habitats Institute couldn't do this by themselves, so they have a lot of people they'd like to thank, including HUD, which is the U.S. Housing and Urban Development Department, grant won by the research consortium consisting of Xtreme Habitats Institute, the City of Nome, Alaska, and Penn State University, along with their funding partners, the Denali Commission, Rasmussen Foundation, Alaska Housing and Finance Corporation, Alaskan National Guard, their technical partners XHab 3D, Cold Climate Housing Research Center, National Renewable Energy Laboratories, Local 528 of the OPC-MIA in both Alaska and Seattle, MTech, SECA, and a special thanks to the tireless workforce at the City of Nome who helped in 1,000 small and large ways. Davis Block and Concrete from Kenai, Alaska, Rick at Hello Central Nome, Arctic Native Brotherhood, Clark and Keith at Builders Industrial Supply in Nome, SWD Urethane for supplying the foam, and Charles Reeder at Q Trucking. Without these people, the project you saw wouldn't have happened. So, big shout out to everyone involved. Hopefully, it won't be the last time they're helping bring a 3D printed construction project to life.